What's that?
I feel like they're going to have a bad experience.
No.
They'll be all right.
They're fine.
Press thicker stop.
Yeah, these are pretty thin stuff. All right, so we're going to talk about multiplying and factoring polynomials. And today we're going to multiply a monomial, and we're going to multiply it by a polynomial. So we have something with one term, and we're going to multiply it by something with a bunch of terms. And we're going to think of this in two ways, or we can think of it in two ways. We're going to either think about distributing, or we can use what we call the box. So we'll do a couple of examples. That's really the best way to think about it. And we've already done this kind of multiplication in the past with the distributing, so it's not really new. But because we're talking about polynomials, we have different things going on with the exponents. Now we know exponent rules, we can do a little more stuff. So let's say we want to multiply x squared by 3x to the third minus 2x squared plus 8. So a monomial multiplied by a polynomial. The first way we can think about this is distributing. And we distribute that x squared to everything in the parentheses. So I'll write this out. That's 3x to the third times x squared minus 2x squared times x squared plus 8 times x squared. Everything multiplied by x squared. And now we're going to simplify this. Well, here I have x to the third times x squared. What do I do with the exponents here? Add. So there's going to be 3x to the fifth. And then I have a minus 2x squared times x squared. Add the exponents. And here I just have plus 8x squared. So we distribute that x squared to everything in the parentheses. Now the other way we can think about this is the box. And for the box, what I'm going to do is write the x squared here and the other one up here. 3x to the third minus 2x squared plus 8. And then I'm going to draw a box here.
This is another super great way to multiply.
Just another way to organize yourself and to think about it. Yeah. And now I'm just going to multiply the two sides of each box. So here I have 3x to the third.
Right.
So yeah, I'm doing 3x to the third times x squared. Here I'm doing minus 2x squared times x squared. And here I'm doing 8 times x squared. And then I do the multiplication. So now I get the 3x to the fifth minus 2x to the fourth plus 8x squared. So the box method is just another way to keep us organized when we do the multiplication.
And down the road, you might not have to put that you're multiplying both of those. You might just put that little answer that you're multiplying to in the box.
Right, as we get better, as we get more familiar with the rules of exponents, we would look at this and say, oh, 3x to the third times x squared is just 3x to the fifth.
Yep.
I'm just making all the steps concrete so we see exactly what we're doing for each part.
Or you get the answer the same way.
Yeah, it's the same answer. Same. And then again, we end up multiplying x squared by everything here, just like we did there. It's just different ways of thinking about it. One way's not better or worse. It's just whatever works for you. When things get more complicated, I have students in my Calculus 3 class that multiply polynomials with a box. It helps keep you organized.
I like it. It's probably my favorite way to multiply.
All right, let's look at another example. 3x to the third times x to the fifth minus 3x to the fourth plus 8x minus 2. First way I'm going to do it is by distributing. So I distribute the 3x to the third times everything. You don't have to draw the little arches. It just reminds you to do the distributing.
Or you can do them one at a time and do them. You'll find a way.
All right. So for the first one, we have x to the fifth times 3x to the third minus 3x to the fourth times 3x to the third plus 8x times 3x to the third and minus 2, I'll just put it down here, minus 2 times 3x to the third. So here I have x to the fifth, and I have the 3 here, so that comes out front. We don't have anything to combine with that 3. X to the fifth times x to the third is x to the eighth. Here I have a negative 3 times 3. I multiply the numbers, so I get minus 9. X to the fourth times x to the third is x to the seventh. Add the exponents. Here I have 8 times 3. Multiply the numbers. 24. X times x to the third. This is x. X is x to the 1. So I get an x to the fourth. And here I get minus 2 times 3 is 6. X to the third. So here where I have two numbers, I'm multiplying the numbers together to get this number that I get out in front of my variables. If I use the box method, I would do it like this. So here I have x to the fifth times 3x to the third minus 3x to the fourth times 3x to the third, 8x times 3x to the third, and negative 2 times 3x to the third. So the box is just a way to keep the process that I did here organized in a different way. But when I do my multiplication, I get the same thing. That was my final answer. All right, questions on this process? Hopefully it's not that new and surprising. This is very similar to exactly like things we've done in the past, where we distribute to everything inside the parentheses and do our multiplication. All right, so our next step, the next thing we're going to do is take something like this and take it apart into two things that are multiplied together. So we're going in the reverse order. And we call that factoring. Factoring turns out to be probably one of the most important operations in algebra. Solving equations, getting x by itself, is one. Factoring is the other. Our first step in factoring is always going to be find what we call, we'll abbreviate it as GCF, which is the greatest common factor.
How many of you have heard of that before? Yeah, Shouldn't be new.
And we find greatest common factors with numbers. The biggest thing that will go into all of it. That's how we think of the greatest common factor. But we're going to have numbers and variables. So let's look at an example. 6x to the third minus 15x squared plus 12x. Now, as you get better at this, you won't necessarily have to do just the entire process that I'm going to do here. But what I'm going to do is list the factors, list all the things that are multiplied to give me 6x to the third. So I'll write over here, list factors. So 6x to the third is 2 times 3 times x times x times x. Negative 15x squared is negative 3 times 5 times x times x. And 12x is 3 times 4 times x. Yes?
Why does it have to be that specific set? Like for 12 students, you do like 6 times 2. Does it have to be that?
So, and I'm going to go further. It could be 3 times 2 times 2 times x. Usually we want to break it down as small as we can.
Okay.
So 6 times 2, you break the 6 into 3 times 2. And now we figure out what pieces all of these have. Well, here I have a 3 and an x. Here I have a 3 and an x. And here I have a 3 and an x. So the greatest common factor is 3x. Because each of these has a 3 and an x in it. And I could think of it as negative 1 times. So the greatest common factor is 3 times x. All right, questions about what we did there? Let's look at another one. 6x to the third minus 15x squared plus 12x. Oh, that's the same one. Sorry. Four x to the fourth plus 8x to the third minus 16x plus 2. Actually, I'm going to do this. Plus 16x squared plus 2x. All right, so let's list our factors. 4x to the fourth is 2 times 2 times x times x times x times x. 8x to the third is, well, 8 is 2 times 4. That's going to be 2 times 2 times 2 times 2 times x times x. 16, oh boy. 16 is negative 1 times 2 times 2 is 4 times 2. This is one too many 2's. I only want 3 2's here. 16 is 4 2's. 2 times 2 is 4 times 2 is 8 times 2 is 16. There we go. I need one more x there. Times x times x. And here we have a 2 times x. Yes?
Do you have to limit the factors, why couldn't you just do 2 times 4 and
We,
have to limit it
we want to break it down as small as we can
to one. Okay.
to make sure we get everything that could go in there.
And eventually, at some point, you might just know that, but we're in the early days of this, so we want to
Right.
break it down.
All right, so I have a 2 times x here. I have a 2 times x here. I have a 2 times x there. And I have 2 times x there. So the GCF, greatest common factor, is 2x. All right, other questions here? Well, now I want to go back to this first problem, and we are going to factor that first problem. So now we want to factor 6x to the third minus 15x squared plus 12x. What factor means is take out the GCF, and then we're going to multiply that by everything that's left. So we know the GCF, the greatest common factor, is 3x. And we found that here. So we're going to put that out front. This is going to be 3x times. And then inside the parentheses, we're going to go back here and say, all right, what's left if we don't include the 3x here? Well, what's left here is 2 times x times x. Well, what's 2 times x times x? How else can we write that? 2x squared. And here I have a negative 1 times 5 times x left for the second part. Well, I can write that as negative 5x. And here I have a 2 times 2 left. So that's 4. And this would be this polynomial in factored form. We can check our work by distributing and seeing if we get back to the original. Well, it's 3x times 2x squared, 6x to the third. 3 times 2 is 6, and x times, yes. Is 3x times negative 5x, negative 15x squared? Yeah. And 3x times 4 is 12x? Yeah. That all checks out. So factoring is going in the reverse of doing this multiplication. Yes?
How did we get 15x squared from 3x times negative 5x?
3 times negative 5 is negative 15, and x times x is x squared.
Remember, when you have just a plain old x, there is an exponent there.
We think it was 1, so we're adding the 1 plus the 1. All right, let's look at another one. We want to factor.
Will they all have variables, Mr. Beamer?
Not necessarily. So we want to factor this thing. No, I'm going to leave it here. I want to erase that 4. All right, so let's factor each term. So 4x to the fourth is 2 times x times x times x times x. Here we have a minus 1 times 2 times 2 times 2 times x times x. And here we have minus 1 times 2 times 2 times x times x. So our GCF is what is included in all of those. So I have a 2 times 2 times x times x, 2 times 2 times x times x, 2 times 2 times x times x. So the GCF is 4x squared. So we're going to pull that out front. And then inside the parentheses is going to be whatever's left. Well, here we have x times x, which is x squared. Here we have negative 1 times 2 times x. So that's negative 2x. And here we have a negative 1. And that's it. And we can check our work. If we distribute here, 4x squared times x squared is 4x to the fourth. 4x squared times negative 2x is negative x, 8x to the third. And 4x squared times negative 1 is negative 4x squared. All right, questions there? Do you want to add anything, Ms. Lindgren?
No, I was just hoping we did an example like that,
Like what?
where we ended up with, no variable.
No variable here?
Yeah, but also one up at the top without a variable too. Like if you put a factoring out without a variable at the end, I just didn't know how much that was in that homework.
Like something like that?
Yeah.
Okay, let's do this one.
Not always a variable.
Right, there's not always okay, that's a good one. Let's factor this one. So I'm going to list my factors. The first one is 2 times x times x. The second one is negative 1 times 2 times 2 times x. And the last one is negative 1 times 2. So the only thing that all three of these have in common is a 2. So I pull the 2 out front, and then I leave inside whatever's left. Here I have x times x, which is x squared. Here I have negative 1 times 2 times x. And here I just have a negative 1. Yes.
Wouldn't the first one of the factors be have 3 x's instead of...
Oh, yes. Thank you. So this should be 10x to the third.
That's a good example because we didn't go descending, increasing, going 0 for exponents.
Right.
Kind of a mixed bag.
Right. And we can check our work. 2x times x to the third is 2x to the third. 2 times negative 2x is negative 4x. And 2 times negative 1 is negative 2. Yes. I'm not. Can you repeat your question? Right. So since we're subtracting, we don't add the exponents. We only add the exponents if we multiply. Okay? All right, other questions? All right, let me do an example. You have one problem that's kind of like this in your homework. That's kind of a word problem. Well, a word / picture problem. This is a square, and this is a circle. And the radius of the circle is r, and the side length of the square is 3r. And we want the area of this shaded part. So the problem I have to do with a circular carpet in the middle of a floor, and they want to know how much of the floor isn't covered by the carpet or something like that.
Swimming pool, you might have seen them as a swimming pool problem with a deck.
Right, something like that. You want to figure out how much fertilizer to buy for your yard if you have a big circular pool in the middle of your yard. Something. We want the area of the shaded part. Well, visually, what we need to find is the area of the square, the entire square, and we're going to subtract the area of the circle. We're going to find the area of the whole square and subtract the area of the circle. So our area is going to be, well, the area of the square is a side times a side. 3r times 3r. The area of a circle is pi r squared. And I'm going to say in factored form here. Well, I can write 3r times 3r as 9r squared minus pi r squared. Can we see what each of these terms has in common without listing all the factors? R squared. Each one has an r squared. So I'm going to put that in front. And if I take an r squared out of here, what am I left with? 9. And if I take an r squared out of here, what am I left with? Negative pi, yes. That would be the area in factored form. About how big is 9 minus pi? About 6, yeah. Because pi is about 3. 9 minus 3 is 6, so 9 minus pi is about 6. All right, so this is our first little step into factoring. We're going to do a whole lot of stuff with factoring. We're going to spend a lot of time on factoring.
Something to look forward to. Right, Mr. Davis?
Yes. I had a
It's
student.
like a whole new world.
I had a student once in Calc 3 tell me, because factoring, we do factoring all the time. And she said, when I first learned factoring in Algebra 1, I thought it was the stupidest thing. And now it's all we do in math. So,
It's meaningful.
yes. All right, our homework. This is section 8.2. Page 495, 10 through 36 even. All right, any questions on the homework from yesterday where we were classifying polynomials and monomials by their degree and their number of terms and all that fun stuff? 34, okay. 34 and 40. Let me stop this recording here.